Okay, so in this question, they just asked us to find the Lorentz series, all possible Lorentz series. Okay. So now, if we look at this, we have 2 points, okay, in the denominator. One is means 2 points are with the function not analytic. One is z is equal to 1, and at z is equal to -2. So these are the 2 points at which our function is not analytic. So now, in order to solve this, we need to make three conditions. Okay, this is -2. No, you could forget the minus sign. Just remember 1 and 2. Okay, for this thing, only for Lorentz series. So firstly, you take mod of z is less than equal to 1. That will be case 1. Then second case would be ignore the minus sign. Okay, so mod of z is greater than 1 but less than 2. We ignore the sign over here because we have taken mod, no, so it doesn't matter whether we take plus or minus here. Then our next one would be mod of z is greater than 2, or we could write mod of basically that only, mod of z is greater than 2. So this will be a case 1, case 2, case 3. Since they asked to find all possible Lorentz series, we need to find all three of these. Let's start with case 1. So we are given that mod of z is less than 1. Okay, but before we start with cases, sorry, I think if we decompose this using partial fractions, that will be more better, no? So you could write our f of z as 1 upon z minus 1 z plus 2 is equal to a upon something upon z minus 1 plus something upon z plus 2. Now just cross multiply, you'll get a into z plus 2 plus z minus 1 into b. Now we can put z is equal to -2. When you put z is equal to -2, this term becomes 0. This will become -3. And if we take it here, we'll get b is equal to -1/3. Similarly, we could put z is equal to 1. Okay, if we put z is equal to 1, this term becomes 0. And we'll get 3 over here. 1 plus 2, 3. And if we take 3 here, 1 divided by 3, so 1/3. So a is equal to 1/3. Nice, sir. So now we can simplify our function and write it as, we'll take 1/3 common, okay, because a and b both have 1/3. So 1/3 is a constant outside. 1 upon z minus 1 minus 1 upon z plus 2. I usually make an error with this minus, so you might also want to keep it in mind. Okay, now we could move on to case 1. Our case 1 was mod of z is less than 1. So let's get with that. Mod of z is less than 1. Okay, so now firstly we need to write this in the proper format. Okay, like 1 upon 1 plus minus something, 1 upon 1 plus minus something. So in order to do that, we just need to rearrange this. If we swap this, okay, basically write 1 minus z, there'll be a minus sign coming up here because we multiply and divide it with the -1. Then here we just take our 2 common. Okay, if we take 2 common out, we'll get 1 plus z by 2. In this case, as both the terms have a negative sign, I just take that out. So now we get 1 minus z minus 1/2 into 1 upon 1 plus z by 2. Now we just use the standard formula. 1 upon 1 minus x ka expansion is 1 plus z plus z square plus dot 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 minus half into is cheese ka expansion, which is 1. Since this is 1 plus x ka expansion, x is this thing, the sign will alternate. So we get 1 minus z by 2 plus z square by 2 square or z square by 4, whatever you'd like to write, minus dot 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 dot. Yeah, you could leave it as this, or you could just simplify and solve it like 1 minus half z minus this. All so it just becomes like one series instead of having two separate series. But I guess this is also fine. Now our case 2 was mod of z is greater than 1 but less than 2. Okay. So function, I'll just rewrite the function here. So we get 1 by 3, 1 upon z minus 1 minus 1 upon z plus 2. If I'm correct? Yeah, finally. Okay, so now we have two conditions. One is less than mod of z, and one is 2 is less than mod of z. 2 is greater than mod of z. Okay. So firstly, we need it in the form of this thing. What do you say? So first, let's consider this condition. Okay, 1 is less than mod of z. We need it in the form mod of z is less than 1. Okay, so we could just divide both sides by mod of z. We'll get 1 by mod z is less than 1. Like whenever you get any equation like this is not an equation. Inequality, equality, no idea. But basically, whenever you get something like this, you can write it as what do you say? First we write it down, then we just shift the term so that we get a less than 1 wala term. We always look for this because whenever we are doing our expansions here, whether this be plus or minus, it could be 1 upon 1 plus x or 1 upon 1 minus x, वैसे. So our mod of x should always be less than 1. So which is why we are looking for this term right here. So we just shift the mod of z here and we get this. So this is one thing. And also we have another condition now. Mod of z is less than 2. Now over here we want less than 1. So we can divide both sides by 2. So we get mod of z by 2 is less than 1. Even that will do now. Now we can move on. We get 1 by 3. Now same thing. Over here we'll be taking z common from this one. Over here we'll just be taking 2 common like we did previously. So if we take z common here, we'll get 1 minus 1 by z here, minus, if we take 2 common here, we get 2 into 1 plus z by 2. Okay. And now we know that 1 upon z or 1 upon mod z is less than 1. So this one is valid. We can use our expansion on it. And this is z upon 2. Okay. So we know z upon 2 is less than 1. So our expansion is valid. So now we could just expand it. The expansion is just the normal. Since this is 1 minus x wala form, we could just all terms will be having a positive sign. वैसे 1 plus 1 by z plus 1 by z square plus dot 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 minus half into, this is 1 upon 1 plus x wala expansion. So 1, the signs will alternate. So 1 minus z by 2 plus z square by 2 square minus dot 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 dot. And this is the case 2 ka answer. And finally, let's move on to case 3. This is the Lorentz series expansion, okay? In case you want Lorentz series expansion, in short, and then mod of z is greater than 2. Yep. So that is the last condition. So f of z becomes, rather I don't need to rewrite the f of z because it's right here. So now we know mod of z is greater than 2, but we want it in the form of less than 1 always, no? So we just take mod of z over here. So you get 2 upon mod of z is less than 1. If this is less than 1, we also know 1 is less than, mod of 1 upon mod of z is less than 1. Obviously, no. If you multiply it with 2 and is less, then obviously if you don't multiply it will be less only. Something like that. So now, the same thing we did here, okay? I think we'll be doing it here as well. So our function will turn out exactly the same up till this step. 1 by 3. Then we take 1 by z common. This is z, okay? And we have 1 upon 1 minus 1 by z minus, over here we need 2 by z, no? Here we had z by 2, okay? So if you take z common, we'll get 1 plus 2 by z, and we'll have a z over here. So minus 1 by z, we took it common, into 1 upon 1 plus 2 by z, which we both know is less than 1, less than 1. This is z here, okay? Wait 1 second. Oh, it's 2z, 2z. Yeah. Now we can take the z common and get 1 upon 3z yeah, okay. 1 upon 3z. I took this z common out, and I'm just writing the expansion for this. 1 plus z, 1 upon z plus 1 upon z square plus dot 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 minus half times 1 minus 2 by z plus 2 square by z square minus dot dot dot. So yeah, I guess this is the needed Lorentz series expansion. And since in the question they asked us to find it out for all possible series, we have case 1, 2 and 3. Yep.